today's lecture. Myself Assistant Professor Tukur Gupta from Ajay Kumar Garg Engineering College, Ghaziabad. The subject that I am covering is embedded system. Subject code is KOE 062. This is the open elective subject. The topics that I am covering in today's lecture are embedded networking. That is, I will introduce this topic embedded networking along with the introduction to the input output devices, ports and buses. So, let us go into details. What is embedded networking? It deals with the network design and topology, hardware devices, communication or data exchange protocols, and all these are needed to connect and exchange the information between embedded systems. So, networking is very important. The communication protocols are very important for designing any embedded application. Why it is so? Because whatever we are using in embedded application, all those things, all those devices have to be connected to each other. Either it is the communication between the devices itself, or there should be the communication between the man and the device. Communication is needed. So, for that different protocols are there, different communication processes are there. So, let us go into details of all these. So, a range of wired and wireless communication options are available. Yes. So, wired is the communication protocols that follow the wired communication, and those protocols which follow the which are without the wired, that is the termed under wireless communication options. Effective design of an embedded networking. When we are talking about the effective design, it requires the selection of a protocol. Yes, the protocol, all the protocols are different in their characteristics, their usage, their advantages, disadvantages, all these things are different for different protocols. So, while designing an application, an embedded application, so the designer should check that which protocol, which communication protocol will be best suited for its application. So, the wise choice should be made, and that enables the desired networking features and communication patterns while managing the design constraints such as the memory and power consumption. So, the constraint such as the memory and the power consumption, these are the main things that we should keep in mind while making the choice for the communication protocols. So, the embedded system form the basis for the Internet of Things also, that is IoT. So, for establishing the IoT, communication devices are must. So, let us go into details. Input output ports. So, in any application, input output ports are very important to establish any communication part. So, receive the bytes from external peripheral for reading them and later using the instructions executed on the processor, or to send the bytes to the external peripheral. So, there are two-way communication, either we are receiving the bytes from the peripheral or we are sending the bytes from the processor to the peripheral. So, this communication is two-way, and later these the instructions are used which are executed to on the processor, which are particular to the processor itself. So, all these things are very important to note. Now, what is a port? It connects through the processor using the address decoder and system buses. So, whatever data we communicate to the peripheral device, or whatever data we take from the peripheral device, how it is obtained or how it is sent or how it is received, that is done using the port only. So, the availability of the ports on any processor or the controller is must. The processor uses the addresses of the port registers for programming the port functions. Yes. So, there are certain ports and certain registers available along with the ports, and for programming the ports, for configuring the ports, we want to make the port as input port or the output port. Is it the pull up register it is connected to the pull up register or not. So, these things we have to note. And how can we configure the ports? We can configure the ports using the registers which are particular to those ports, and these are available along with the ports in every microprocessor or microcontroller. So, we should have the knowledge of those registers also, because we need to configure them to use the ports. So, reading port status for writing the reading or reading the bytes. So, we can also read the status of the ports. We can also give the values to the ports, we can write on the ports, we can read from the ports, we can read the values from the ports, all these things can be done. So, what are the examples of the ports? Like in 8051 there are certain ports like P0 which are named as follows: port 0, that is P0, port 1 is P1, port 2 is P2 and port 3 is P3. Now, in 68HC11 this is another processor, and here the port A, port B, port C and port D, these are the 4 ports. Now, if we see a general purpose computer, that is the IBM PC we can take. So, there are 2 ports are available, that is the COM1 and COM2, these are the communication ports are available. So, these are the examples, these are the perfect examples of any ports. Now, if we want to categorize the ports, then what are the categories? Like there are types of serial ports are there. So, these are synchronous serial ports, synchronous serial input and output, these are separate. Asynchronous serial UART input, asynchronous serial UART output, and these are both as input and as an output, for example, the modem. So, in modem they are both the ports are available, they can be used as the input as well as the output ports. Types of parallel ports: parallel port 1 bit input, parallel port 1 bit output, then the multiple bit input and multiple bit output. These are the options of the parallel ports. Let us see what are these. When we are talking about the input output device type, so these are the device types: synchronous serial input, synchronous serial output, serial asynchronous input and serial asynchronous output, that is the part of UART. Now, what are the examples? Let us see. When we are talking about the synchronous serial input, inter-process data transfer, reading from the CD or hard disk, audio input, video input, dial tone, network input, transceiver input, scanner input, remote controller input, serial input output bus, writing to the flash memory using secure data association IO based card, that is SDIO. So, whenever we write on the flash, whenever we write to the flash memory using SDIO port, that is also the example of the synchronous serial input. What is this? What is the synchronous serial input? As the term is defining itself, that in the case of the synchronous inputs, there must be some clock present. So, all these examples are supported by the clock. Now, synchronous serial output. So, again inter-process data transfer, multiprocessor communication, writing to the CD or hard disk, this is the output process, writing to the CD or the hard disk, this is the output process, this is not the input process. Audio input or output, video output, dialer output, network device output, remote TV control, yes, this is also the output, this is not the input. Now, transceiver output, serial input output bus output, or writing to the flash memory using SDIO. So, this is again the serial output. So, this is synchronous serial output examples. Now, when we talk about the serial asynchronous input, that means there is no clock present and the synchronization of the data bytes are being done using start and stop bits, there is no presence of clock. So, the examples under this category are the keypad controller serial data in mice, then keyboard controller for the then the again keyboard controller, simple keyboard controller, modem input, character send inputs on the serial line. So, this is the example of the serial asynchronous communication. This is also called the UART, that is the universal receiver and transmitter. Now, input when according to the UART mode. So, serial line, when it is following the UART protocol, then that communication, that particular communication is categorized under the serial asynchronous UART input mode. Now, when we talk about the serial asynchronous UART output, output from the modem, output from the for the printer, the output on the serial line, especially when it is using it is following the UART protocol, and so it then that UART output is known as is categorized under the serial asynchronous UART output. So, these are the various examples that can be categorized under the different device types, though, that is synchronous serial input, synchronous serial output, asynchronous serial input and asynchronous serial output. So, I hope all these examples are clear under different categories. Now, again, when we are talking about the input output device, parallel port, single bit input, these are the devices under parallel port. So, parallel port serial single bit input, parallel port single bit output, parallel port multiple bit output and parallel port multiple input and output for multiple bits. Now, let us see the examples. So, when we are talking about the single bit parallel port input, then the completion of a revolution of a wheel, achieving the preset pressure in a boiler, exceeding the upper limit of permitted weight over the pan of an electronic balance. These are the real life examples of the parallel port single bit input. Presence of the magnetic piece in the vicinity or within the reach of a robot arm to its endpoint, filling of a liquid up to the fixed level. So, in all these examples we can see that there is a upper limit and the data is communicated bit by bit, that is a single bit input is there. Now, when we talk about the parallel port output examples, PWM output for a DAC, that is the digital to analog converter, PWM output is the pulse width modulated output, which controls the liquid level or the temperature or pressure, speed or angular position of a rotating shaft or a linear displacement of an object or ADC motor control. All these are the examples of the parallel port output. Pulses. Now, another example is the pulses to an external circuit or control signal to an external circuit. So, as we all know that whenever we give the pulses or the control signals to any external peripheral device, then those pulses are given bit by bit. So, that is a perfect example for the single bit parallel output. Now, when we talk about the multiple bit parallel input, then ADC input from the liquid level measuring sensor or temperature sensors or pressure sensors or speed sensor or DC motor RPM sensor. So, whenever we obtain the inputs from the various sensors, those are in the form of the multiple input bit parallel port. Encoder inputs from the bits for angular position of a rotating shaft or a linear displacement of an object, that is also the example of the parallel port input, multiple inputs. Now, when we talk about the parallel port multiple bits output, LCD controller for multi-lane LCD display matrix unit in a cellular phone, that is used to display the screen on the phone number, time, messages, character outputs or pictogram bit images. That is the example of the parallel port multiple bits. Now, the print controller output, stepper motor, coil driving bits, these are the multiple bits and in the parallel mode. So, as we can see in these figures that this is a synchronous serial input device, there is the device, this is the data I0 to I7, this is the 8 bit data, this is the timeline, that is the this is the time t. These are the bits, okay, these are the blank, this blank, these are the blank bits. Now, serial input port, this is the port, and the two things are important in this synchronous serial input device, serial bits and a clock signal. So, these two things are must for this communication. Synchronous serial output device, again output bits, these the hashed lines, these are the output bits shown, that is O0 to O7. So, these are the 8 bits. Now, this is the serial output port and this is the clock. These are the data lines. So, in this way the serial port is there. Now, when we talk about the synchronous serial input or output port, okay. So, there are two types of ports, either the half duplex or the full duplex. When we talk about the half duplex port, that means the communication, two-way communication can take place at that particular port, but one at a time. Either the data will be received or the data can be sent, not simultaneous process cannot take place. So, that is the half duplex. In case of full duplex, both the communication, that is the reception and transmission both can take place and simultaneously also, that is the full duplex mode. So, the perfect examples for the half duplex is the walkie talkie, and for the full duplex mode is our mobile phones that we use, or the modem. So, in modem both the reception and the transmission takes place. So, synchronous serial input, the sender along with the serial bits sends the clock pulses. This is the main part of serial of the synchronous serial communication. The port synchronizes the serial data input bits with the clock bits. Each bit is in each byte as well as each byte is synchronized. That is, in synchronous serial communication, bytes are also synchronized with the same clock, with the common clock, as well as the bits within the bytes are also synchronized. Synchronization means that the separation is there by the constant interval, that is synchronization. If the clock period is T, capital T, then each byte, if the clock period is capital T, then each byte at the port is received at the input with the period 8T, yes, because there are 8 bits. So, the bytes are received at the constant rates, each byte at input port separates by 8T, and the data transfer rate or the serial line bits is 1 by capital T bits per second. So, 1 BPS is 1 bits per second. So, this is how there is the regular interval, there is the constant interval between the bytes. Synchronous serial input is used for inter-process transfers, audio inputs and streaming data inputs, because they need the synchronization. So, when we talk about the synchronous serial output, then again each bit in each byte is sent in synchronization with the clock. Bytes sent at the constant rates. If the clock period is T, then data transfer rate is 1 by T BPS, that is the bits per second. Sender either sends the clock pulses at SCLK pin or sends the serial data output. Yes. So, both these things are synchronized. Synchronous serial output using shift register. What is this? So, there are certain registers, that is the shift register, and the data is stored in that shift register and is shifted bit by bit. So, the processing element at the port, that is the peripheral, sends the byte through a shift register at the port to where the microprocessor writes the byte. Synchronous serial output is used for inter-process transfers, audio inputs and streaming the data outputs. So, in this way the shift register is also used while outputting the data at the output port, and it more effectively streamlines the output process. Asynchronous serial output, in this asynchronous mode there is no need of the clock. Synchronization is obtained by using the start and stop bits. So, asynchronous output serial port line, that is the transmit data line. Each bit in each byte transmit at the fixed intervals, but each output byte is not in synchronization. So, on contrary to the synchronous serial output mode, in this mode there was a clock that set up the synchronization, but here the clock is not there, the start and stop bits are only used to make the synchronization. So, it separates by variable interval or phase difference. Minimum separation is 1 stop bit interval, that is the transmit data. Does not send the clock pulses along with the bits. Okay. So, the clock pulses are not sent in this scheme. Sender transmits the bytes at the minimum intervals of n(t). Why n(t)? Because there are n number of bits. Bits are not, so there may be a variable number of bits. The bits receiving starts from the middle of the start indicating bit. Yes. So, whenever the start indicating bit is sent, then at the middle of that bit that particular data is sent. So, n can vary from 0, 1, 10 or 11 and sender sends the bit through the 10 or 11 bit shift register. So, this is how the data is shifted and data is sent through the output port. The examples for this is output from the modem or the printer. So, as we know that there is no need of perfect synchronization in case of modem and printer. So, these asynchronous mode of communication can be used in these cases of modem and printer. So, as we can see in the diagram, there is the start bit, data bits, parity bits, stop bit, and this again the serial data. So, this is how the sequence is maintained. Again when we talk about the asynchronous serial input, again there is the receive data line. Okay. So, again the clock pulses are not there, each bit is received in each byte at a fixed intervals, but each received byte is not in synchronization. Bytes separated by the variable intervals or phase differences. Asynchronous serial input also called the UART input if serial input is according to the UART protocol. So, the example is the keypad inputs and modem inputs in computers. This is the perfect example for asynchronous serial input. So, as a conclusion, as I have already discussed that there are the modes of communication, 3 modes of communication are there. Basically, they can be broadly categorized into 2, that is the simplex and duplex. In the simplex mode, either the medium is sender or receiver can be active at a time. So, either the sender is active or the receiver is active, not both cannot send the data simultaneously. So, for the perfect examples are television and radio. So, in the television and radio, so there is only one way broadcasting, only the data is received at our end, we cannot communicate from our side to the radio or the television. So, this is the simplex mode of communication, only the one way communication is there. If we are talking about the duplex mode, there are 2 types like half duplex and the full duplex, as I have already discussed. In the half duplex, both way communication can take place, but not at the same time, that is example is walkie talkie. So, when the communication from the one way is over, then the communication from the other way can start. This is the protocol in the half duplex. Full duplex means that both the communication, 2-way communication can take place, that is in case of the mobile phones. So, that is the example for that. And another example is the communication between the modem and the computer through the transmitter and the receive data lines, or communication using the SI modes 1, 2 and 3. These are the modes of serial communication in 8051. So, the protocol that is followed in these examples is the full duplex communication. And the last, there is a bus system, that is the processor, memory and input output hardwares, these are connected through the system bus. So, this we have to note that there is a bus in every microcontroller or microprocessor, and the bus comprises of the data bus and our control bus and the memory bus. So, all these that is the address bus, and all these buses work together to make the system bus. So, this is how this communication system is completed. Thank you. That is all for the day.